Going to discuss about the fractional index change. Okay, what do you mean by fractional index change, or how you are going to write the fractional index change? The fractional index change is going to denote by a delta. So if fractional index change is nothing but it is the difference of these two core and cladding. For example, in an optical fiber, you take one optical fiber, you take an optical fiber. Okay, this is optical fiber, this is optical fiber. Okay, core is there and cladding is there, n2 and n1, all these things is there. The optical is sorry, the fractional index is going to determine or the obtained by an expression n1 minus n2 divided by n1. What is this? Actually the mathematically whatever is there, this is the pictorial representation, and verbal is that it is the reference of, it is the ratio of difference of refractive index of core to cladding to the refractive index of core. How? This is the, for example, this is small one, this is the core minus this is a cladding. Okay, don't write in the exam this same, and divided by core. Okay, so this is the n1 n2 by n1. This is going to be denoted by delta, or mathematically you will write delta is equal to n1 minus n2 divided by n1. This is the fractional index change. Okay, sometimes he may ask what is the relation between the fractional index change and numerical aperture. We know that what is the numerical aperture? Numerical aperture is equal to n1 square minus n2 square as per when it is in the air. Okay, when it is in the air. For example, there is a small difference between the core and cladding of small difference between the refractive index of core, refractive index of cladding. Therefore small diffraction. Okay, then n1 plus n2 can be written as 2n1. n1 minus n2 can be written as difference of delta n1. Okay, because small difference is there, therefore okay, n1 is nearly equal to n1. That's it. Okay, plus means 2 and minus means this is the difference. If such case na can also be written as in this fashion. Okay, what is that? n1 square. Okay, n1 square minus n2 square is 0. This can be written a square minus b square can be written as n1 square minus plus n1 into n2 and n1 minus n2. We will split it again. n1 plus n2 nothing but 2n1 into, okay, n1 minus n2 means delta n1. So this will n1 into n1 again n1 square. Therefore numerical aperture is equal to, okay, 2 times of, okay, delta into n1 square. This is the root. If you take out the root n1 square outside, therefore n1 into 2 into delta. Okay, this is under root. This is the relationship between numerical aperture and the fractional index change. This will complete the fractional index change. So another one important bit we are going to discuss. What is the mode of propagation? What is the mode of propagations? Okay, you know that, okay, when we have the core is having some diameter, and we have the cladding having some diameter. So there is a, if based on the core diameter, cladding diameter, the chances of light introduced from one end to the another end is quite different. The number of modes are there like this. The number of modes are there like this. The number of modes are there like this. Okay, these modes, okay, or maybe based on the angle of incidence introduced into the core, that is higher, axial and highest. What is the higher? What is the axial? The light travel from the along with the axis, that is called axial mode. When making some angle, this is called the higher mode. Then making smaller angle, this is the highest mode. These are the three different modes of propagations, or simply we can define the modes of propagation means the number of directions are propagating from one end to the another end based on the diameter. That is called the modes of propagations. That is called the modes of propagation. That is mainly categorizing into two, along with the axis, and that is axial, along with making some angle, this is the lower end, another one is the higher, or he may write higher, highest. These are the so these these modes of propagation, modes of propagation is depends upon purely the diameter of the core and cladding, that is near about from 10 micrometer to sorry 10 micrometer to 200 micrometer. Okay, 10 micrometer of diameter of core to 200 micrometer. Naturally, if the core diameter is increases, the cladding diameter is also going to increase. The cladding diameter, it may be 50 micrometer to 250 micrometer. So this way we are going to provide. How we can determine the number of modes? We have a parameter. What is that? We have a parameter. That parameter is called V parameter. Based on the V parameter, we can determine the modes of propagation. What do you mean by V parameter? The V parameter is going to denoted by pi d by lambda into na. Okay, na. Or we can say that the parameter V is equal to pi into d divided by lambda. In a numerical aperture is nothing but we know the formula n1 square minus n2 square under root. These are the, here lambda is the wavelength what light it is moving here, and n1 is the refractive index of the core, n2 is the refractive index of the cladding, d is the diameter of the core. Based on these parameters we can determine the V number. Using these V number, or V is very smaller than the one number, then the number of modes can be determined by using the parameter, that is n is equal to v square by 2. Okay, then we know, wait, when we know that v square is equal to what? V is equal to pi square d square by lambda square n1 square minus n2 square into whole square. This is the v square divided by, okay, 2 is there. Therefore this can be written as, okay, simplify this, pi square d square by the 2 lambda square into n1 square minus n2 square whole square. This is the formula for getting or obtaining or finding the number of modes. Okay, this concludes the number of propagation or number of modes. Okay.